Hi friends, good morning. Welcome to my channel, Master. We are discussing the series Target Kcet 2026. In this series, we are discussing the chapter as Integration to Part 3. In this Part 3, today we are discussing the topic is substitution. By using substitution also, frequently they are asking questions in Kcet friends. So now we are going to do integral cosecant x by cos square 1 plus log tan x by 2 into dx. So this kind of questions definitely you need to take by using substitution. Then we need to solve. Without substitution, it is very difficult to solve. So, by using substitution is what we need to take the substitution from the given question. If you observe carefully, 1 plus log tan x by 2, if you call some t, then the sum will become very easy. For example, you are not going to get any idea while solving the integration substitution. Once look at the answers. Sometimes 50% of the questions, by observing the options, you can able to get it the substitution. If you see the question, almost in all options 1 plus log tan x by 2 is there. Means your key factor is 1 plus log tan x by 2 only. So that's what you are going to call, put 1 plus log tan x by 2, let it be called t friends. Now differentiate with respect to x. You are going to get 1 derivative 0. Log x. Log x derivative 1 by x. What is x? Tan x by 2. Into function of function. Tan x by 2 derivative. Tan x derivative secant square x. X means what? X by 2. Into that x by 2 derivative is 1 by 2 dx is equals to dt. So very simple differentiation. Then this can be written as, look at tan x by 2 can be written as sin x by 2 by cos x by 2. I'm going to write cos x by 2 in the numerator into secant square x by 2 can be written as 1 by cos square x by 2 into 1 by 2 into dx is equals to dt. Let's move to here. Cos x by 2 get cancelled. 2 sin x by 2 cos x by 2 is nothing but what? Sin x. So you are going to write 1 by sin x dx is equals to dt. 2 sin x by 2 cos x by 2 is sin x. 1 by sin x can be written as cosecant x dx is equals to dt. Now these values you are going to substitute in the given question. The question will change. Integral cosecant x dx is there in the numerator. We are going to write it dt by cos square. This total part we are calling as t. That's what this is t. 1 by cos square t can be written as integral secant square t dt. So what is the integration of secant square x dx? Tan x, right? So this is in terms of t. That's what write on tan t plus c. Question in terms of x. Answer also should be in terms of x. That's what, just you need to replace t value. What is the value of t? 1 plus log tan x by 2 plus c. So which option correct among all? Tan of 1 plus log tan x by 2 plus c. Option 2 is the correct answer, friends. So very simple. Just you need to get the thought as 1 plus log tan x by 2 equal to t. If you don't know, look at the options. So can I solve second question? So this is the second question. Integral 1 by root x plus x root x dx. So if you see this kind of questions, so before you are going to take the substitution, you need to simplify the question. After simplification, is there any possibility to take the substitution? Look at it. So now root x and root x is there. You can take root x as common. So 1 by root x, if you take common, you are getting 1 plus x dx. If you observe in your options, so root x plus 1 is not there. That's what, there is no substitution on root x plus 1. If you observe in the remaining three options, root x is there. So somewhat substitution is there on root x. So I want to call, put root x is equals to t. If you apply squaring on both sides, why? Because here root x I called as t, but here x is required. So x required means when you are going to get x, if you apply squaring on both sides. So if you apply squaring on both sides, x is equals to, you are getting t squared. Now differentiate with respect to x. X derivative dx. T square derivative 2t dt. So this problem can be changed as integral 1 by root x we are calling as t. 1 plus x is nothing but what? T square into dx is nothing but what? 2t dt. So t and t get cancelled. 2 constant, keep it outside. 2 into integral 1 by 1 plus t square dt. Almost completed the sum. Integral 1 by 1 plus x square dx. Everyone knows very well. Tan inverse x plus c. Now it is in terms of t, right? You write down in terms of t. This is nothing but 2 tan inverse t plus c. In terms of x, answer should be in terms of x only. That's what 2 times of tan inverse of t. What is the t replacement? Root x plus c. So which option correct? 2 tan inverse x plus c. Option 4 is the correct answer. So this kind of sums are very easy. If you don't know the substitution, look at the options, try to understand. According to that, take the t, then you simplify. You will be getting the answer, friends. Can you see a few more examples in the same model? More examples in this model, friends. Integral 1 by x square into x power 4 plus 1 whole power 3 by 4 dx. This is the most important. This is the 2025 Kcet entrance examination question, friends. So if you see here, look like x power 4 plus 1, x power 4 plus 1, x power 4 plus 1 by x power 4, x power 4 plus 1 by x power 4 is there. So look like x power 4 plus 1 is equals to t as the substitution. But what is the problem if you take x power 4 plus 1 as t? Okay, so the derivative of, after taking the substitution, let us imagine the derivative, x power 4 derivative 4x cube. But 4x cube is not there in the numerator. So if you take x power 4 plus 1 is equals to t as a substitution, there is no use. So that's what this kind of questions what you are going to do means you are going to solve, take x power 4 as common. You are going to take out of the bracket that x power 4. So then if you take out, you are going to get 1 by x square into x power 4. I am going to take common. Whenever you are going to take x power 4 as out of the bracket, this 3 by 4 also carried this. Hope you understood. Into x power 4 out means 1 will be remaining by 1 plus 1 by x power 4 whole power 3 by 4 into dx. Okay, this one step only difficult. If you understood this step, remaining part is very easy, friends. 4 and 4 get cancelled. This can be written as 1 by x square into x cube remains here. So x power 5, 1 plus 1 by x power 4 whole power 3 by 4 into dx. Clear? Now if you take LCM, you are getting x power 4 plus 1 by x power 4. Look at x power 4 plus 1 by x power 4, x power 4 plus 1 by x power 4. These two options wrong. From these two, any one of the options is correct. Clear? Now you are going to take, put this part 1 plus 1 by x power 4, let it be called t. Differentiate with respect to x. 1 derivative 0. So 1 by x power 4 can be written as x to the power of minus 4. Then apply differentiation, n into x power n minus 1. Minus 4 minus 1 minus 5 dx is equal to dt. Then this can be written as 1 by x power 5 dx. Keep here. And minus 1 minus 4 keep the other side. Minus dt by 4. Why? Because 1 by x power 5 dx is there in the question. These values you are going to substitute in the given answer. So this is equals to integral 1 by x power 5 dx can be written as minus outside written dt by 4, the constant keeping outside. Then this part I call as t power 3 by 4. Clear? Everything is finished. This can be written as minus 1 by 4 integral t power minus 3 by 4 dt. This can be written as minus 1 by 4 into integral x power n dx can be written as x power n plus 1 by n plus 1 plus c. Minus 1 by 4 into t to the power of minus 3 by 4 plus 1. If you take LCM, 1 by 4 by 1 by 4 plus c. 1 by 4 get cancelled. You are getting the answer as minus t power 1 by 4 plus c. Now, question in terms of x, that's what answer also should be in terms of x. So, t value you need to replace. Now, t is nothing but this part. Minus of 1 plus 1 by x power 4 whole power 1 by 4 plus c. If you take LCM, you are getting minus of x power 4 plus 1 by x power 4 whole to the power of 1 by 4 plus c. So, option 3 is the correct answer, friends. So, only the thing is, you are going to take x power 4 as out of the bracket. That is the most important point. Once if you know this one, the rest of the part will be very easy, friends. Let us move to next. Integral sin x by 3 plus 4 cos square x dx. What to do? Very clear, friends, here. So, cos x, sin x is there. So, clearly you can able to call cos x is equals to some t. So, if you call cos x as t, put cos x is equals to t. So, differentiate with respect to x. Cos x derivative minus sin x dx. That minus, I am sending the other side, minus. So, can I substitute all the values in the given question? This will be integral. Sin x dx is nothing but minus dt by 3 plus 4. Cos square x, cos x is t means t square. Now, minus is keeping outside, and also from here, 4 is the constant. So, functional constant, both are involving means constant, we need to take it out. So, this can be written as, so minus outside and 4 is also outside in the denominator. You are getting integral 1 by, so whenever you are taking 4, this will become 3 by 4 plus t square dt. Now, this is t square format, that's what constant also converted to a square format. This can be written as minus 1 by 4 into integral 1 by root 3 by 2 whole square. Root 3 whole square 3, 2 square is 4 plus t square dt. Almost the problem is completed, friends. As minus 1 by 4 into integral 1 by x square plus a square dx. The formula for integral 1 by x square plus a square dx equal to 1 by a tan inverse x by a plus c. So 1 by a, what is a here? Root 3 by 2, I am writing by 2 here. Into tan inverse of x by a, x is t, by a is nothing but root 3 by 2 plus c. This can be written as 2 to the cancel, minus 1 by 2 root 3 into tan inverse of this 2 will become here 2 into t. T is nothing but cos x. Question in terms of x given. So that's what answer also should be in terms of x by root 3 plus c. So which option correct, friends? Minus 1 by 2 root 3 into tan inverse of 2 cos x by root 3 plus c. Option 1 is the correct answer, friends. This is what the substitution method, friends. So substitution method is also very easy. So whenever you don't know the substitution of any question, once you look at the option, definitely you will be getting a hint from the options to take the substitution. According to that, if you follow, you will be getting the answer, friends. This is the best tip for substitution, friends. That's all for today's class, friends. Thank you so much, friends. Thanks a lot.